This conference will now be recorded.
What is service? All of you? No one? Okay. So, guys, the problem what we have in the cluster, let's visualize that. I'm not using slides because it will get delayed more. I mean, lots of time we have to spend. So this is the cluster. Simple. Now here we have front end clusters which you can say red. One, two, three, four. Now we have backend cluster, database cluster. Wow. Which color I wanted to change? One, two, three, four, five. Now each pod you have IP address. I'm talking about the internal communications. Okay. So now the problem is we have a few front end cluster which is in red. Now the question is this red will connect to this or this or this or this or this. This is the problem, and this is the problem for the each front end pod. Are you able to understand this problem? Which pod the front end will connect to? That's one problem. Second problem, this pod will keep coming and going because of scale in, scale out, or some other node issues. The IP address will change actually. So how can we hard code that front end to back end? This is a problem which we have. All of you are able to understand that, right? Let's engage in the discussion. That will be easier for us. All of you.
Yes, Rajesh.
Yeah. So how do we solve it? Simple. Then you will say, okay, what's big deal? Let's use the uh, let's use the load balancer. Load balancer for what? Pod. Here you have to use load balancer for pod. So here you have this pod from front end, and I need one. This is the backend pod, and I need one load balancer here. Okay, and this load balancer should load balance this pod in a cluster. Okay, and load balancer should have some X IP address. So that means now its life is easier, correct? This load balancer is having IP address.
Sorry, Rajesh, are you recording the session?
Yes, yes, I just
Sorry.
started.
Thank you. I'm sorry to interrupt. Thank you.
Yeah. So this load balancer is called service. So what is service? Service is the load balancer. But there are two types of load balancer. Primarily we use it. Anyone would like to tell me what is that? Two type sorry, two type of load balancer. Anyone would like to tell me? So
Think application load balancer, network load balancer, right?
correct, 100% correct. So which one is this? Is it application or network? So this is the
Application
network. No, this is the
network
network.
is it?
Yeah, this is the network. And then if you want application, then you have to in Kubernetes. If you want an application, then you have to go for one API resources, which we call it ingress. Okay, ingress. So ingress is application load balancer. Service is a network load balancer. Okay, so what is happening? This service will redirect the traffic to the pod network, pod port. This is the network IP address. So this service has a some check inbuilt. So if this pod is available, then only it will transfer the traffic. It will not. It will not transfer the traffic to the not healthy pod. Pod is ready, then only transfer the traffic. Now the question is, see, this pod is keep coming and going. You did scale in, scale up, scale out with the deployment yesterday, correct? So more replicas, more pod, less replicas, less pod. Node is going, pod disappear. So the question is in my mind, who will update this load balancer, this service with right IP address? Only the functional IP address. Who will update it? These questions, if you have, then then you should understand there is a one component which is called core DNS. Have you seen that, all of you? Core DNS.
Yes.
Yeah. So what is happening? Please hear me out carefully. I'm trying to, uh, minimize the cost of, time of discussion because I have many other topics also. So the problem I said, problem is only the active and healthy pod should be load balanced by service. Now pod is going destroyed, terminated, new pod is coming, new IP address is coming. So how this service will update himself? Very simple fundamental. Service you can label it and pod also you can label it. Label means you understood that labels you have seen that in the pod, right? All of you?
Yes.
Yes,
Yeah.
yes.
So the logic is very simple. The moment the labels of pod matches with the labels of service, okay, labels of pod matches with the labels of service, that means those pods, let's say this is the matching, so only these two pod will be load balanced by service. Simple logic. Labels of pod, if it is matched with the labels of service, those pod will be load balanced by service. Simple. Is it clear? So who's going to label it? Of course you are going to label it. This is your job to label it. You should. So if anyone, let's say, I don't want to load balance this pod, so you can label it, but it should not match with the service label. Make sense? All of you? Hello?
Yes, yes, sir.
Okay,
Yes,
guys.
but Rajesh, where is the code DNS coming to picture? What is the usage of code DNS here?
So the question is, who will update the labels? Who will have a data? Who will have a record of labels? So DNS server is a place where you have a labels and IP address record, functional IP address record. Okay. So basically, service will ask through API server to core DNS saying that, hey, I have this label, give me that all the pod's IP address which is matching with my labels. Got it? So DNS server, why we use it? DNS server will have a name plus IP address. That's a collections you have. Correct now?
Mm-hmm.
So it will ask, hey, give me the name of the IP address which is having matching with my labels. So this internal function, sorry, sorry. So internal function, they will manage it and then they will have. Now guys, one thing also I want to tell you, what I said, very simple. What I said, labels of pod matches with the labels of service, then those pod will be load balanced by service. This statement is very clear, but here I will add asterisk sign, condition apply, because I'm not teaching you right one. Then you'll say, why not? Then this is easy for understanding for time being. But when I show you the demo in 5 minutes, okay, I will change the line little bit of it. Okay, because I don't want to talk that line now, you'll get confused. So for time being, labels must match. of the pod and service, those pod will be load balanced by service. That's it. Okay. So now you understood that service is a load balancer. Let me sum up. Service is a load balancer. Which load balancer? Network load balancer. What algorithm? Random load balancing. There are multiple algorithms also there, right? So service is a random load balancing. Okay. So service only balance the healthy pod, okay, and the logic which I said how it works, which pod will it will load balance, which pod it will not, and so on. Now a service scope is important. So if you have understood so far, then I can discuss a little bit more also. All of our understanding.
Rajesh, one question. So load
Hmm.
balancer is a process, right? Or is it a physical?
See, this network level load balancer is a process. I'll put it in this way. Mm, it's like kind of playing with IP address. Okay, every host. Okay, if you write a rule to transfer the traffic to some other IP. Okay, so service you can say is not a process. Service you can say is like updating the route table and IP tables, and based on the traffic they automatically route to the right pod. So that is what is being done actually. So service is a more or less playing on the IP table, route table, and node port and all stuff like that. Getting my point?
Um, I mean, I get what it's doing, but I don't get what it is. I mean, is it the master node is the one which has, I mean, does this kind of things, or is it the Q proxy
Mm,
which does this? Something like that. I don't
mm,
understand.
no, 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 no. This is not the way. Uh, uh, and I'm putting in the simple way, okay? Again, networking session is pending, so there also we'll discuss a little bit of it. So this is a one machine, and this is a another machines. Okay. Now this is a master. This is a worker, okay, and this is the
Okay.
worker. I'm putting at a very high level because I don't want to get into that networking topic right now. What happened when I say service? So service is a one API resources which does something. What he does? So do you remember that you have kube proxy in each worker,
Yeah.
and you also know that we have a driver, networking driver. For us, we are using Calico,
Yes.
correct?
Yeah.
And host level also we have IP table and route tables. IP table which collect the all the IP addresses which you have, the pod is here, and the route table where to transfer it. Okay, so in simple way, this is a part of the kernel functionality, IP table and route table. Now, then you must be thinking, where is the service? So, service is doing nothing but functions to update the IP table and router table through kubeproxy. Okay. So now when the traffic come always to this place. From the outside, traffic come to here. Okay. So when you get the traffic, then they will say, so what traffic? So you'll say you are hitting to the service IP address. Service IP address. So service IP address, the it will be registered here also in kubeproxy. Both will understand, and we'll check that the for that particular service where to route the traffic. So this queue proxy will decide, okay, let's try transfer to this because in IP table and route table for this routing rule is written, if anyone hit the service IP address, it should go to this one. If it's not having those pods is not running this machine, then it will send back the control saying that this is called ARP request. I am not having that route set. So it's not a software, you can say. It's a service is something like to update the networking layers for having right IP address. I don't know whether you understood or not.
Okay.
Getting my point? Yeah.
Um,
So if you want to understand this concept, how this is taking place, then learn about Ethernet. That's one question. VEth, okay, bridge IP table and route table, and how this OSI model works. Then you'll understand that.
okay. Okay. Yeah.
Okay, so now I was talking about something else. Uh, I was talking about something. Yeah. So that is okay. So you understood the service so far, right? That's one of the API resources. Clear? All of you?
Yes.
Okay, now I will tell you the scope of service. This topic is very important, okay? So please focus. So here, this is the cluster, and this is the worker. There's one worker, two worker, okay? And the cluster scope, you saw that. So now let me create a one front end pod. This is the front. This is the front end pod, and this is the back end pod. Now, guys, for the back end pod, I need one service, correct? Very simple. Backend pod, I need one service. So this service has IP address. This also IP address. This also IP address. And when someone hit to IP address of service, service will route that traffic to the one of the healthy pod. The algorithm is random load balancing. So far so good, right? All of you. Hello.
Yes, Rash.
Yeah. So now this service, you know what? This service you can access from outside also. If you're inside one of the node, one of the worker node or master node, then directly you can access this service. I'll show you through the demo. So that's not a problem. So do you want to access service pod of the backend? Of course not, right? Don't want to. What you want to access? You want to access front end. So I need to create one more service. So this I created one more service which is load balancing the front end pod. Now service, this service also has IP address. So if you are inside a cluster, you can access this one and you can enjoy the applications that is there. So this logic you understood so far? This logic you understood so far?
Yes, Rash.
Okay, but that guys, the problem here is our end user is outside, no, not inside. And the scope of this service, the IP address of a scope of this IP address service IP address is local to the cluster, not worker, local to the cluster. So how he will access it? Because if he's trying to access this front end service, he cannot reach it. Correct now? So what should I do? What should I do? This is a problem which we have. So guys, this service, there are three types of service which primarily we have it. Though it's a four type actually. I'm only discussing three. Three. Guys, this service, the one which we have, this service and this service. This service got the IP address from the cluster. So that is the reason we call it clustered IP. It's cluster IP service. This service got IP address range within a cluster. So they will sorry. So then we call it a cluster IP. But the problem is how can we access that service from outside? That is a problem. Anyone have idea? If you think you will have idea for sure. Anyone?
What's the question, Rajesh?
The question is the service is accessible within a cluster, but our end user is outside of the cluster. So how can end user access the front end service?
We need to define an ingress, right? It sits on the boundary of that cluster.
No, no. Ingress is a different concept altogether. I'm not
Is it
confusing you.
you by configuring NAT?
But we said no Kubernetes networking requirement. NAT is not allowed.
Okay.
Port forwarding.
Yes, 100% correct. Port forwarding. You did it actually. Port forwarding, you did it with the pod. Yes, guys. Pod forwarding, you did it with the pod, so you can do with the service also. What I'll do, simple thing. This service I will expose. I'll change the colors, you'll remember. This service I will expose where? At the node port. So this service I will expose at the node port here, and this service I'll expose. Same command actually, by the way. And this port, and now this guy can access this node port. Agree with me? Agree with me?
Yes, Rash.
Okay. So guys, creating, please hear me out. I'm not writing too much. Creating a service, creating a service and exposing the service at the node port. Each call that service called node port service. Simple. Here, the service which you are exposing at the node port, port forwarding at the node port, that service we call it node port. So that means when you create a service and when you say, hey, I want the node port service, then in that case, one clustered IP service will be created and that service will be exposed at the node port. So that is the reason we have a type node port also. Understood node port service? All of
Yes,
you?
yes.
But,
Yes, yes.
but guys, tell me one thing. In reality, do you really access the IP address of the application? Like Facebook is telling, oh, okay, this, add this, access this IP address. No, what they do? I can't keep hitting the IP address of node. This may there, this may not there. And if all the end users will hit the IP address, so all the traffic will go to the only one node because one node will be heavily occupied and other nodes will not. So what to do? How do we solve the problem? The problem here is very simple. I'll repeat. There are hundreds of workers and one person is confused which one to choose. So how do we solve this? End user. How do we do that? So that is where guys we will create one more load balancer. Mind it. We will create one more load balancer. This load balancer will balance what? Node. See, service is a load balancer for pod. Okay, service is a load balancer for pod, and load balancer, the one which you see outside of a cluster, is load balancing the node, and port forwarding a service to the certain port node will connect these two networks together. Are you thinking it or not? This load balancer is outside of the cluster. This load balancer will balance the node port node. So who is managing a node for you? For me, it's managed by AWS. So I can create a load balancer there. Okay. So now user will hit the load balancer of node, that is a very comfortable for the user, and the load balancer will decide based on this whether this worker or this worker, and the work if service is exposed anyways you have to, then from that node port it will go to the front end service, from front end service it will go to the front end pod, from front-end pod, hard-coded is with back-end service, and back-end service will transfer the traffic to one of the back-end pod, and the whole traffic has been fulfilled. Are you understanding this flow, all of you? All of you? Hello? Hello? Am I audible?
Yes, yes, we're getting it.
Yes, Rajesh.
So this load balancer will be created by whom? AWS. Managed by whom? AWS. Those who manage your VMs, worker and master, they will create. Okay, so you can do this load balancing manually also, create manually or automated way. So in automated way, what will happen? You have to go and use LB, Kubernetes LB. So Kubernetes will do, you know what? When you say, hey Kubernetes, please create the load balancer, I mean service which is a scoped till a load balancer. Then what Kubernetes will do? Kubernetes will create one clustered IP service and then expose at the node port and then request AWS. Kubernetes will request AWS, hey AWS, create a one load balancer and I'll give you the IP address which need to be balanced. And after that, get done. So LB is the one which is final step. So now it's easy. Load balancer, you got it. But primarily you don't hit the load balancer. What you hit? You hit the DNS server. So DNS server you can configure this load balancer. So you remember www.devops.school.com. Devops transfer this traffic to load balancer. Load balancer will transfer out this traffic to one of the worker to the front end service to the front end pod to the back end service to the back end pod. This is the whole communications will happen. Whole flow will be like this. Understood, all of you?
Yes, Rajesh.
Yes, Rajesh.
So, so this is the whole flow. Load balancing, node port, cluster IP. There is one more which is external IP. I am not discussing because this is not as part of this image. So you'll get confused. So I don't want to confuse you too much. Okay, so now I'll show you the demo for this. So let's get started. Okay, so let me start the demo. So this is my workstations. Let me log in. You all have to work on the same machines. So same credentials, same username. Only IP address got changed. Today we'll work together and accept. Username is Ubuntu and sudo hyphens. Now I'll just make this better. So guys, demo, please focus on it. It's very important. I spent almost 6 months to understand this whole concept in 2015. It was very confusing for me also. Okay, so you see here, you get notes. Here it is working. Now, what I'm going to do, guys, because we all are working in the same directory, so under the root, I will make one directory, Rajesh. So I'll not fight with you. So Rajesh, and then I will go and do everything from here. Okay, so now I need a pod. So where's the day1.txt? So this is the pod. Where's the pod? Here it is. Okay guys, so this is the pod. Now this pod I will make it name pod1 for myself. Image I'll let it be same, and here two pod I need it. So one pod and pod 2, and this image I'll make it v2. Why I am showing you? Basically service should have a same image, similar application, but I want to show you whether load balancing is happening or not. So here v1 and v2, this pod 2, pod 1. Okay, so just for load balancing feature. So vi pod 1 dot YAML. Guys, if you get confused, please ask for the questions. I will answer. This is the pod 1 and this is the pod 2. Vi pod 2 dot YAML, and here save it. Done. Now what I'll do, I'll just see that kubectl get pods, how many pods we have. So there's one deployment running. I'm cleaning it up. Kubectl delete deploy, name of the deploy, deploy done. So here terminated. There is one more plugins which is pod which is there, which I want to delete it. So none pods. Just for clean demo, I want to show you. It's not I was not having any issues with that. Right? Apply -a pod 1 ctl apply -a and pod 1 dot 1 pod 2. So guys, I got a 2 pod. I'll just confirm kubectl get pods -o white. Now I'll just validate both the pods is resulting v1 v2. So far so good, all of you?
Yes,
Yes,
sir.
sir.
Yes.
Yeah, just a second. Okay, so now what I will do, I'll create a service. Guys, how to create a service? Actually, you know the my tactics, you know that more or less. So here I'll not explain and drag this topic more. So create svc -h. See here, what type of you want? I explain you. Cluster IP, external port, load balancer, node port. So you have to decide. I'll go with the cluster IP, which is the default. So here, cluster IP -h. Now, just spelling mistake maybe -h. Now I got this command to create a cluster IP service. What is this? Here. Now here you see kubectl create service cluster IP, name of the service, and this is the service port and container port on port container port is this one, which is fixed. So I'm creating service. So here the screen here created kubectl get svc, which I am going to svc. See here, the service is created. This is the IP address of service. This is the port number of service, and its target IP is this one. You can describe also, and you can see that describe svc my -cs. See here. So target port is 80. Now here endpoint, here you see none. So what I said, none means this is the place where if service is load balancing any pod IP address will be mentioned. Right now none. What I said, What I said, guys, please mind it. What I said here, get pods hyphen hyphen show labels. So if labels of service and labels of pod matching, the load balancing should happen. Agree with me, right? So
Yes.
labels of pod is here, labels of service is here. So can I match this? So here app is equal to hello world. So guys, I'm editing that service. All this command you know now. I don't have to teach you each and everything. Now labels match this. Now pod labels, service labels. Matching or not?
Yes.
Yes.
Now let me see endpoint is getting updated or not. See, no, that means the service is not load balancing any pod. That's bad, right? Because I said if the labels of pod and labels of service will match, then it will happen, but not. So, guys, I taught you wrong things actually. I taught you wrong things. So I told you no condition apply. So here I am revising and correcting the statement. Please hear me out clearly. The labels of pod must match with selector label of service. Then only load balancing will happen. Not a label of service, selector label of service. That means this service is saying, hey, uh, select those pods for the load balancing at endpoint where this labels is there. Sorry, this label is there, selector label. So it's not match with the labels of service. It should match. It must match with the selector label of service. Are you understanding, guys?
Yes.
Yes.
Okay. So now let me do that. So edit this service. I don't care what is the label of service. Here I'll modify, but this one go to the selector level of service. And where is that? Here it is. Save it. Done. Clear and describe. See here. Magic. Understood? So cube state here. Get SVC. Here. This is the one. Curl. HTTP. What is the port number? 5678. See. Now I want to see load balancing is happening or not. So watch it. V2, V1, V2, V1. Understood now how this load balancer works in the servers? All of you?
Yes. Right. Yes.
Good.
Yes.
Great. So guys, I want to create one more service. kubectl get svc. I created a clustered IP service. Now, as per the discussion, I want to create a node port service. So when you call the node port, what will happen? Node port service will create a clustered IP service also, but that service only they'll expose the node of every worker of every cluster. So how can I do that? So I think you know my practice. Create SVC node port hyphen h, and this is the command you got. Now I'll just copy this, and here, see here, this is the service port, this is the port, and node port automatically defined by Kubernetes. So don't worry about it. So let's run this. Here, done. You'll see it here. Get SVC. See, this is the node port. But if you look at this node port, also got a cluster IP. But one additional things you got it at the node port. This is the node port got occupied. Worker port. This is the service IP address. So it's load balancing. It's not load balancing because selector level is not matching. So NS. See here. Not updated endpoints. So what to do? So here hello world, I have to add it in selector level. So edit this, go to the selector, hello world, save it, see, done. So now I can access the node code also. So qctl and get svc, see here. So now curl, testing the service first. This is the IP address, port number 5678, right? Yes, accessible. But this is the port number, okay, and the node IP address. So what is the node IP address? Here, this is the one, and I can have to copy 530476. Right? So now it's accessible on the node port. Agree with me, all of
Rajesh,
you?
one question. Yeah,
Huh.
got it. And one question. This node port in the sense like any node I can use, right? Any node IPs I can use. Suppose, for example, if I have 5 node
Yes,
cluster.
yes,
Uh,
yes. Wonderful. So what is happening when you run the node port? Please hear me out this statement. When you use the node port, then what will happen? Please hear me out. It create the clustered IP service, and that service get exposed to each node of the cluster. That means you can use it at every node of the cluster. Got it?
oh, okay. So that means we can that is one more small clarification. So in that case, when we are exposing as a node port, the port is assigned for the particular service will not be repeated in
Hmm.
any of the other service. It will be unique, right?
Hmm.
Okay, thank you. If you don't mind, one more question. If I want to restrict
Hmm.
only particular nodes only, it has to allow a traffic. Is there any possibility can we do?
Particular node?
Meaning, suppose for example, I have two master and
No,
three
no,
worker
no. So,
nodes.
no, no, no. This
Mhm.
you are thinking is using like a cattle. So, sorry, pets. You have to think as a cattle business. In the production, you don't do that kind of customization.
We cannot control the traffic only particular like inbound traffic, particularly in this node and
You
outbound traffic.
no, no. You can control. You can block certain node, some port number and all, security groups
Okay,
and all, firewall. You can do that, but we should not do that like that in the production side.
okay.
Yeah,
Thank you.
customization will be allowed, but in the production server, we don't have that kind of thing.
Thank you.
Okay, so this is the something which you have. Okay, so this is a node port I showed you. Now load balancers will not work. Why? Because for the load balancer, this is external load balancer. So even though if you run it, it will go into the pending stage. Why pending stage? Because Kubernetes has no access to the AWS directly right now. We have not configured into that. So what I will do, just for the demo sake, I'll show you this. So I'm going to create manually load balancer. So here I'm creating a classic load balancer. This is Raju load balancer port, node port, and security groups, default selected. And next, which instance? These two, review and done. So this I created for the AWS, and this is out of service. Okay, so let's see that. See here in service. So this is the load balancer now. This is the endpoint of the load balancer, and here. Now, see, scheme. That means this external person can access this load balancer. Are you agreeing with it, all of you? All of you? Hello? Hello, guys?
Yes, Raj.
Rajesh.
Yes.
Yeah. Now, last thing, DNS server. So this DNS server, how do we configure? So we can configure like this. Let me do that for you. This is my production server. So taking advantage of using Route 53 service, and done. Save it. And now, guys, anyone, I'm as this here xyz dot devops.com. Anyone in the world, they will hit, they'll get this one, this DNS. Can you validate if someone is getting the v1 or not? Click on this URL in the chat and see. Anyone is getting v1?
Yes, sir. Getting you.
Cool. So guys, did you understand this, how this end-to-end flow works? So from DNS to load balancer, power managed by cloud, load balancer to the worker node port, from worker to service, service to the pod, and multiple service you can have it. I represented only two service here in this demo, but it can be multiple microservices. Did you understand that now, all of you? All of you?
Yes, Rajesh.
Yeah. So guys, this is the one. So now you will not be able to create this load balancer. You can try node port, clustered IP, and node port. So all the commands and code you have it. I'm updating that a2.txt. By now you know that more or less. So let me do that.